Hi everyone, this video will introduce you to the concept of polynomials. This video in particular will teach you a few things, specifically what a polynomial is, different ways that you can classify polynomials, and introduce you to some basic operations in terms of addition and subtraction with polynomial expressions. As you're going through this video, feel free to copy these notes onto a blank copy of this that I have posted as a PDF in Schoology. You can find it in the distance learning folder. It's titled Unit 9 Notes. Feel free to copy this, whether it's on your iPad or print it out. If it's easier, feel free just to watch the video and copy down what you need to, take in what you need to. However you need to do it is fine with me. However, I do suggest, no matter what you decide, watch this the whole way through to make sure you get all the concepts and that you don't miss anything. So, let's talk about what a polynomial is. And to understand what a polynomial is, you need to know what a monomial is. A monomial is a variable, a number, or a product of a variable of a number. So, a couple of examples here. The number 91, that's a monomial. It's a singular number. X cubed, that's a monomial. It's a singular term, a variable, whether it has an exponent or not, that you can see, that's a monomial. If I combine them together, since they're being multiplied together, that's one singular term. 91x cubed would also be a monomial. Where you get polynomials is when you take more than one monomial, put a plus or a minus sign in between them, and attach them together. So a polynomial is a sum of monomials, or a difference, if you will. So an example would be 9x plus 7. That's a polynomial, because you have more than one term being attached by a plus sign. X squared minus x plus 3. That's a polynomial because, again, you have multiple terms. They're being attached by plus or minus signs. That's what we're going to be taking a look at here throughout this chapter. Again, we're looking at the basics of them in this lesson and the next one, and then we're going to go do some different math with it as we move forward throughout Unit 9. Couple of components about polynomials that'll be helpful a little bit in this class, but more when you get into Algebra 2 next year, when you start actually really diving into polynomials that have a lot of squares and cubes and fourth powers, etc. We're going to look at what's called the degree of a polynomial. And what the degree is, it's simply the highest exponent term that you can find. So that'll basically tell you how the function will work, especially graphically. Now, again, in this class, you don't really do too much other than straight lines. Algebra 2, you're going to see a lot of things where you have squares and cubes and all kinds of stuff, and you'll see how all those different things interact. But the degree has different words attached to it. I don't need you to so much memorize them, but I'll be referring back to these a lot throughout the chapter, so it is going to be helpful to know what I'm talking about here. A degree of 0, okay, so an example would be a plain number like 10. That is a constant, okay? Anything that has no variable is a constant, has a degree of 0. A linear term has a degree of 1, so like 2x. So there is no exponent that you can see, but there is a variable, which means it has the invisible exponent of 1. A quadratic would be an x squared, cubic, x cubed, quartic, x to the fourth. And you can have degrees that are beyond that, but then you start running out of names. So, and these are the most common ones that you'll run into in your time probably learning math here at the high school. The other thing that you'll see are what we call leading coefficients. The leading coefficient is the number in front of the term with the greatest degree. It's pretty self-explanatory there. This, again, you'll mess with more in Algebra 2, where the leading coefficient will kind of give you an idea as to how things graph and interact and all that stuff. A couple other keywords to know. Different types of polynomials have different words. Monomial is a polynomial that has only one term, hence the prefix mono. Binomial, the prefix bi, means 2, so 2 terms. Trinomial, prefix tri, would mean 3 terms. Quadrinomial, you get 4 terms with that prefix quad. And beyond that, they're mostly referred to as polynomials once you get to 5 terms and beyond. There are a few instances where you'll see expressions that are not polynomials. There are 3 instances. If you see a variable in the denominator of an expression, if you see a negative exponent, or you see a variable as an exponent. If any of these 3 cases pop up in an expression, it is not a polynomial and it does its own thing. So we'll see a couple of examples of that as we go through here, but that's just something to keep in mind. Those we won't really be working with here in this chapter. This is just more to identify what is a polynomial and what isn't. So on this first part of the page here, we're going to look at some expressions here where we're going to identify the degree and the leading coefficient, but we're also going to write them in standard form, aka writing the expression from the highest degree term to the lowest, so reordering our terms. Number one here, we're going to identify the degree. The degree is going to be our highest exponent, which in this case is a 4. So that negative 4b to the fourth term, that has the highest exponent, that has a degree of 4. To write this in standard form, I'm going to start by putting the negative 4b to the fourth term first. The next highest exponent is the 3b cubed, and then finally the b squared. Make sure you pull all the appropriate signs with it, pluses and minuses, to make sure it still has the same value. Your leading coefficient is out in front of the problem, and it's really easy to find when it's in standard form. It has to be in standard form for you just to rip that front number off. The leading coefficient there is negative 4. Second example, same idea. I have myself a degree of 3 because that's my highest exponent. So negative x cubed is going to go first, then the 15x, and then the negative 3 at the end. My leading coefficient is negative 1. I know you don't see a number there, but again, the invisible number that's out in front that you can multiply to would be 1. It doesn't affect it. That's why my leading coefficient is negative 1. My final problem here, my final expression, I have a degree of 9. That's my highest exponent. So if I put this in standard form, negative 2y to the 9th would come first, then 9y cubed because it has the second highest exponent, and then the negative 5y at the end because that has the lowest exponent, meaning my leading coefficient would be negative 2. So that's how you take these expressions. You put them in order. Again, degree, highest exponent, leading coefficient. Once you put it in standard form, it's simply the number out in front. Now, the last part of your notes here, so you'll see I kind of cut and paste from the top part here so you can kind of see this as a reference on the same screen. We're going to take a look at that chart at the bottom of the page where we're going to determine if things are polynomials or not. If it is a polynomial, we're going to list the degree, and we're going to classify by the number of terms. If it's not a polynomial, we're going to simply explain why it's not. So, as we're going through this here, if you want to try this on your own before looking at the answers here, please feel free. If not, follow along here and you'll get all the explanations. So for our first one, we have 5y squared. That is indeed a polynomial with a degree of 2. It is only one singular term, so this is a monomial. The next one, 3a to the negative 5th, is not a polynomial. We're not going to worry about the degree with things that aren't polynomials, and the reason why it's not a polynomial, it has a negative exponent. That's one of our 3 things that'll prevent something from being a polynomial. So negative exponent, doesn't matter how many terms there are, if you see any negative exponent, it is not a polynomial. The third one is a polynomial with a degree of 4. It has 3 terms. It is referred to as a trinomial. Fourth example, not a polynomial, and the reason being there is a variable in the denominator. So that's one of our, again, 3 reasons why something cannot be a polynomial. Fifth example is a polynomial. A couple of terms to choose from. The highest exponent I see is 5. So we have a degree of 5. There are 2 terms. This would be a binomial. Our sixth example is a polynomial. It's just the number 9. Since there's no variable, there's a degree of 0. And again, 1 term. It is a monomial. Next example, another polynomial, has a degree of 2. There are 3 terms, so it's referred to as a trinomial. Eighth example is once again another polynomial. Highest exponent is 4, and it's made up of 2 terms, so here we have another binomial. The second to last example is another polynomial with a degree of 3. 3 terms, trinomial in this case. And our last example is not a polynomial. The reason being, variable is an exponent. Purpose more behind this is you're going to hear me refer to a lot of these words, monomial, binomial, trinomial, a lot of times. More just so you understand where I'm pulling these words from and what they mean. Okay, so that's more the emphasis behind that than anything else. And again, the degree part, while it's functional in a lot of different ways, you won't use it too much here in Algebra 1. It's something you'll see a lot more in Algebra 2 because it affects a lot of things graphically when you have different degrees of different functions. But again, that's some of your basics on how to classify polynomials, how to identify some different pieces, degrees, leading coefficients, etc. So what we're going to transition this into now are some basic operations. This lesson, we're going to continue with addition and subtraction. In the next lesson, you'll learn how to do some things with multiplication. So let's talk about how to add and subtract polynomials. These are things you've kind of done already way earlier in the year, but the way that we referred to it was combining like terms. This is going to be pretty much the same idea. The only real difference is that we're going to have more terms in these cases. What we did earlier in the year, I think, was maybe add a couple of terms together, and they were really small terms, etc. Now we're going to see things with more exponents, higher degrees, etc. Adding and subtracting are pretty much the same deal. The difference is this. When you add, you just got to combine like terms. That's it. When you subtract, you have to make sure that minus sign affects everything after it. Okay? Because remember, subtraction is a little bit more orderly than addition. Addition's commutative. I can order it however I want. Subtraction, you have to be careful. You have to make sure that subtraction sign affects and applies to everything after it. So let's take a look at the 4 examples up at the top of this page, and then we'll take a look at the perimeter examples at the bottom. So here in number 1, we're going to find the sum, because we got a plus sign in the middle, of these 2 polynomials. Now, as we're going through this here, I'm going to put a lot of different colors and grouping symbols. For some of you, that might be helpful. Some of you might not need to do that at all. Whatever works for you, again, is totally fine. So I need to figure out what terms are going to combine together. Since it's just addition, we're just combining like terms. I see a couple of x cubes. I see a couple of x squareds. I see one regular x. And I see a constant. So all I'm going to do from here is just combine all the terms that I have with the same symbols and the same colors. So 4x cubed and x cubed. Keep in mind, when you're adding and subtracting, exponents never change, just the coefficients in front. So 4x cubed and what's essentially 1x cubed make 5x cubed. Please do not make that 5x to the 6th or 5x to the 9th or something weird, okay? If you're adding or subtracting terms with variables, the exponents on those variables do not change. Now I'm going to put the squareds together. So I have 1x squared minus 3x squared. That'll make negative 2x squared. The 7x and the negative 5 don't go together, so I simply just pull them down with their appropriate signs, and I'm done. Notice how I started with the highest degree term first. Again, writing things in standard form just makes things a lot easier to look at, especially, again, when you're doing this, in a typical classroom setting here and I'm grading things on paper. It's a lot easier for me to look at and see your answers if they're in the correct order rather than jumbling through terms. It keeps things nice and neat and organized. So again, when you do this, try to make sure that you're putting them highest exponent to lowest. Number 2 is the same idea. We're adding once again. So I'm going to go ahead and put the squareds together. I'm going to put my x's together. And I'm going to put my constants together. So if I have x squared and x squared, so again, if you need those invisible ones, put them in. X squared plus x squared is 2x squared. Now I have a positive x and a negative x. Well, 1 minus 1 is 0. They cancel out. So if they cancel out, I don't need to write 0x. I'm not going to write anything at all because they cancel out. Now I have 8 minus 1, which is positive 7. And I have a final simplified answer of 2x squared plus 7. So that's addition. When we do subtraction, there's a couple ways you can certainly do this. The way that I prefer it, because what I tend to see is a lot of people messing up the signs, take the minus sign and distribute it to everything that's after it. I want you to rewrite the problem, where the first term is going to, the first expression, I should say, stays the same. The second expression, we're going to apply that minus sign. So the 11t to the fourth is going to become negative. The negative 3t squared becomes positive. By doing that, your signs will more than likely be correct, which will make your combining like terms more likely to be correct. So now it's just a matter of, again, what do we need to put together? So we've got ourselves a couple t to the fourth terms, a couple of t squared terms, and a regular t term. So I have t to the fourth minus 11t to the fourth. That's going to be negative 10t to the fourth. 3t squared and 3t squared makes 6t squared. And then the negative 5t gets tacked on at the end. So it just becomes like the addition problems from up above once you apply the minus sign to everything, okay? So that's kind of also a nice little trick that makes this a little bit easier. And you don't have to think of too many different processes. Same thing in number 4. I'm going to apply that minus sign to everything after it. So I'm going to pull down the 3x squared plus 6x minus 4. The x squared is going to become negative. The negative x is going to become positive. The negative 7 is going to become positive. And now, again, I just have to combine my like terms. So 3x squared and negative x squared will go together. The 6x and 1x, negative 4, positive 7. So I put my x squareds together, I'll get 2x squared. Put my x's together, I'll get 7x. Put my constants together, I will get positive 3. So that's the basics on how you add and subtract. And again, that shouldn't look too unfamiliar to stuff that we've done earlier in the year. Again, it's just that you're going to see more terms involved. A way that we can apply adding and subtracting polynomials is with a concept of perimeter, which is certainly a concept you've learned at some point. But all perimeter is taking the sum of all side lengths. So if you're measuring on your own, you just simply add up the numbers. In this case here, we're just going to add up some expressions. So here I give you a four-sided figure here. I give you a quadrilateral. We're going to write an expression that represents the perimeter of the figure. All I'm going to do is this. I'm going to take my four sides. I have x minus 1 plus x plus 4 plus x plus 5 plus x plus 1. That's going to be my initial expression to write. Again, all I'm going to do is combine my x's and then combine my constants. So I have 4x, x adds up to 4x. Add up my numbers, that comes out to 9. My perimeter is going to be 4x plus 9. My last example here, again, it's the same idea. So here's another quadrilateral. It kind of looks like a trapezoid. I'm going to do the same thing. I'm going to write an initial equation here. P equals, I'm going to add 2x, 3x minus 2, 2x plus 1, and 5x minus 2. The biggest thing here is just not to double count any sides or forget to count something. So once again, I'm going to add up my x terms, and I'm going to put my constants together. So if I add up my x's, let's see here, we end up with 12x. I put my constants together, I have negative 3. So my perimeter is equal to 12x minus 3. Now, there is a very brief follow-up here, nothing too tricky. If x equals 4, what is the actual perimeter of the figure? All you have to do to figure that out is simply plug 4 in for x. Quick PEMDAS, 12 times 4 is 48, minus 3. The perimeter based on that x value would be 45. There are no units here, so you don't have to make one up. We'll just say the perimeter is equal to 45, and that will be your final answer. So, this concludes your first lesson here on Unit 9, how to classify, how to add, and how to subtract polynomials. Your homework, or I guess I should say your assignment that goes with this. So with each lesson, you will get some sort of assignment that will count for a grade. Your assignment that goes with this will be on IXL for today. It'll be one topic within level K. On IXL, you want to do topic Z.4. Okay. Z.4 is focusing solely on adding and subtracting. Okay, so you'll definitely want to make sure you take your time. It doesn't give you really wiggle room to make too many mistakes, okay, or really any mistakes at all. So make sure you're taking your time and typing things in. I would definitely suggest on a separate sheet of paper writing out some work to make sure you don't make a bunch of silly mistakes. So again, the assignment in this for today will be on IXL. As we go throughout this chapter and the following chapter after that here in these next few weeks, some of the assignments will be done on IXL. Some of them will be done either like Schoology quizzes or worksheets or something to that effect. So not everything's going to be IXL, so don't feel like it's going to be all the same thing all the time. But some of these do align very nicely to IXL, and then it's easy for me to grade, and it's easy for you to get feedback as well. If you have any questions whatsoever on this assignment, by the way, as a reminder, if you want full credit, same grading as always, target score of 80. That'll get you an 8 out of 8 if you hit that or anything above it. If you have any questions on this assignment or anything in the lesson that you viewed, please definitely get a hold of me, and I will be more than happy to walk you through anything. If you're struggling with IXL problems and constantly getting stuff wrong, please, again, contact me, and I'll be happy to help you out. Thanks for watching, and we'll talk to you next time.